Welcome to the Morning Walk with Murty Digital Stroll. Today, we are looking at a really fascinating paradox.
It really is.
Right. Like, why is an artificial intelligence that can, instantly compose a breathtaking, multi-layered symphony in the style of Mozart completely losing its mind when you ask it to sing a simple 500-year-old Telugu poem?
It just completely falls apart.
It does. It's a profoundly fascinating path ahead of us, and it's specifically tailored for your mission with Project Antaryami lead architect Murty BVNS. And before we take another step, I really want to acknowledge a fellow traveler spark that just completely illuminated today's path for us.
Yeah, that was a huge breakthrough for our prep.
Seriously, some incredible deep research from Perplexity.ai really just reframed how we were looking at this entire puzzle.
It did. And that spark was exactly what we needed to see the larger architecture at play here. Because, we are not just here to summarize technical manuals or read text out loud.
No, definitely not.
We are actively looking through the digital prism. Our mandate for this Gurukul session is to extract the vital legacy code for Project Antaryami. So we're auditing the bridge between ancient acoustic wisdom and modern generative models. And as you well know, building that bridge requires understanding the exact stress points where the materials fail.
And what a massive stress point it is proving to be, right? Let's unpack the central frustration of this migration. We are looking at cutting-edge AI music models.
Massive ones.
Yeah, massive, highly touted engines like Google Labs Flow. Yet when we attempt to feed them ancient Telugu or Sanskrit devotional stotras, these, highly structured devotional hymns, they just stumble spectacularly.
It's almost painful to watch.
Right. You try to digitize the rules of Indian classical music, and the machine doesn't just fail, it actively rewrites the source material.
Yeah, it's the defining friction between Silicon and Sanskrit. To extract this legacy code successfully, we first have to deconstruct the fundamental architecture of the system that is currently failing us.
Okay, let's do it.
Let's look closely at Flow Music, which is powered by Google's Lyria 3 Pro model. When you input a sacred Telugu Kriti, which is a very specific format of musical composition in Carnatic music, you are expecting the AI to act as a faithful archivist.
Right, you want a perfect one-to-one translation from text to audio.
Exactly. But Flow is a text-to-music generator designed with one primary, inescapable directive, and that's creativity. It is built for iteration, not preservation.
So when you paste in the exact meticulous lyrics of a saint composer like Tyagaraja, and you're expecting a perfect word-for-word rendition, what is the AI physically doing behind the scenes, like in its neural network?
Well, it's treating your input as mere inspiration, like a jumping off point.
Wow, just inspiration.
Yeah. The model looks at the text, processes it through its natural language layers to extract a general sentiment or, vibe, and then it maps that to a latent audio space.
So it's basically saying, I get the mood.
Right. Its neural pathways essentially conclude, I understand the emotional vector here. Let me generate a completely original melody and just paraphrase the lyrics to match this feeling.
That is so frustrating for preservation work.
Oh, absolutely. Under the hood, consumer AI tools have their temperature settings, which is the metric that controls randomness and creativity. They have those locked at a high baseline.
Mm-hmm.
Google explicitly emphasizes that Flow is designed for restyling beats, translating and transforming songs.
Transforming, yeah.
It is algorithmically actively avoiding rendering existing works note for note.
The structural mismatch here is just staggering when you look at the cultural grammar involved, because models like Flow, they understand broad Western, pop, hip-hop, electronic, cinematic textures.
Broad washes of sound.
Exactly. They learn these broad stylistic washes from their training data, and if a pop song is a little loose with its melody, it still sounds like a pop song.
Right, the listener forgives it.
But Indian classical music, whether Carnatic or Hindustani, demands a rigorous, almost mathematical grammar that absolutely does not tolerate broad washes.
Precisely. It is an architecture of absolute precision. You're dealing with strict scale rules.
Right, the strict rules of the Raga. You have the pakad, those very specific, characteristic melodic phrases that define the actual soul of the Raga.
You can't just guess those.
No. And you have intricate vocal ornamentation, the gamakas, which aren't just, decorative flourishes that you can skip. They are structurally essential to the melody.
And then there is the absolute rhythmic discipline of Tala, the cyclic rhythmic framework, a general-purpose AI trained on billions of parameters of Western pop, just sees music as a sonic texture.
It just sees texture.
Yeah, it literally lacks the dimensional parameters to recognize the explicit ancient theory governing that texture.
And beyond the musical mismatch, there's another layer, right? The modern-day guardrails.
Oh, the copyright and safety filters.
Yes. Large music models are heavily constrained by their creators to avoid reproducing copyrighted melodies and lyrics too closely. I mean, they want to shield the parent companies from massive litigation.
Which makes sense for pop music, but
But this is where I find the logic of the machines so incredibly frustrating. Composers like Tyagaraja or Annamacharya lived centuries ago. Their work is the very definition of the public domain. Why would an advanced copyright filter care about a 300-year-old composition?
because the filter mechanism is a blunt instrument. It does not possess historical nuance. It relies entirely on pattern recognition.
So it just sees familiar text and panics.
Basically, yeah.
Yeah.
When you feed in a highly famous, highly structured piece of text, even a public domain stotfret that has been digitized across the internet, the system's pattern matching flags it as known existing material.
Interesting.
It doesn't check the date of authorship. It just knows, I didn't invent this text.
Yeah.
So the safety mechanism triggers automatically, forcing the model's temperature higher, pushing it to generate new mutated text rather than chancing a faithful reproduction.
Just to avoid a potential copyright strike.
Exactly. It forces a mutation just to be safe.
To put this in perspective, it feels like it's like we are taking a brilliant world-class jazz improvisation engine, sitting it down in a silent temple, and demanding it to recite the Vedas perfectly.
That's a great analogy.
Right. The AI's very DNA, its underlying algorithms, are designed to riff, to improvise, to swing the beat. But the spiritual tradition of these stotras demands precise, unbroken, phonetic transmission.
The Gaz engine literally does not have the capacity for strict orthodox recitation. Its neural weights prioritize variation over fidelity.
That is a perfect way to look through the digital prism. The core architecture is just completely misaligned. So, since Flow's fundamental design is entirely wrong for the strict cultural preservation required for Project Antaryami, we need to scan the Gurukul 2.0 horizon.
We have to audit the alternative platforms. We need to see where this legacy code actually could be migrated today.
Let's start by looking at the absolute cutting edge of research, just to see what the future holds, even if we can't integrate it into a pipeline right this second. There is a fascinating prototype out there called the Raga multi-track music model, or RMMM.
Yes, the RMMM is highly significant because it serves as a proof of concept.
That the math works.
Yes, it proves that Raga-respecting AI generation is computationally possible. But it achieves this through a completely different neural architecture than what consumer tools use.
How so?
It relies on highly specialized, meticulously curated datasets of classical performances, explicitly tagged with Raga rules.
Wow, okay, so it's very manual.
Extremely. It is a brilliant laboratory experiment, but it requires heavy back-end compute and custom dataset management. It's not an API-ready tool you can just deploy today for a daily architectural workflow.
So if Flow actively rejects the rules and RMM is still locked in the research lab, what happens when we look at dedicated consumer platforms? Let's evaluate Musicful, because they actually feature a dedicated Indian classical music generator.
You do, yeah.
It allows you to paste in lyrics in Telugu, Hindi, or Sanskrit, and you can explicitly prompt the style, like Carnatic Raga with sitar and tabla, slow tempo.
It does allow that, and it generates a complete song. It creates tracks that use classical scales, but we must be incredibly precise with our terminology here. It generates Raga-inspired tracks.
Inspired, not accurate.
Exactly. It captures the atmosphere, the timbres of the sitar and tabla, but an expert Carnatic musician, or an architect like Murty migrating legacy code, would immediately spot the theoretical flaws.
Because it misses the picade.
Yes, it misses the picade, it hallucinates the gamakas. For a casual user wanting a certain mood, it's impressive.
Yeah.
But for architectural preservation, atmosphere just isn't enough.
Which brings up the crucial question, right? If Musicful lacks that strict theoretical rigor, how do we solve the underlying mathematical problem of the Raga?
You need a different tool entirely.
Right. That requires a model that bypasses pop aesthetics completely. And that is exactly what Sargam AI was built to do. If Musicful is the enthusiastic art student, Sargam AI is the strict, unrelenting theory purist.
Exactly. The mechanism behind Sargam AI is entirely different. It does not rely on massive text-to-audio linguistic datasets.
What does it use?
It utilizes deep frequency analysis and spectrogram reading. It analyzes traditional acoustic recordings specifically to identify the mathematical relationships of ragas, the cyclic patterns of tals, and the exact frequencies of microtones or shrutis.
So it truly understands the physics of the music.
It does.
Yeah.
But this creates a massive bottleneck for Project Antaryami. Sargam AI is phenomenal for instrumental generation. If you want to simulate an alapana, the unmetered melodic improvisation that introduces a raga, it is unparalleled.
Unparalleled, yes.
But does not handle vocal lyric generation.
Okay.
It analyzes the acoustic properties of a sitar bending a string, not the phonetic complexity of a human mouth forming a Sanskrit vowel.
Ah, I see. It masters the math of the raga, but is completely deaf to the language of the singer.
And this is exactly where I have to push back on a very common assumption about the broader generative AI landscape.
Oh, what assumption?
Well, we've established that the specialized tools lack vocal capabilities.
Sure.
So you might look at the behemoths in the room, Suno AI and Udio AI. These are the titans of multi-language song generation.
Right. Udio handles over 10 languages, and Suno reports support for around 50 different languages.
Yes, and you can input custom lyrics, choose a prompt like Indian classical, Carnatic devotional, and they will generate a full track with stunningly clear vocals.
Very clear, studio quality vocals.
But here's the challenge I want to pose to you. If Suno has this vast multi-language capability, if it can process 50 languages perfectly well in a pop context, why does it still hallucinate?
Oh, that's a great point.
Why, when we feed it exact Sanskrit words, does it sometimes just make up gibberish that sounds vaguely Indian?
It is such a vital distinction, and it comes down to how these LLMs process language versus how they process rhythm. We really have to separate linguistic dataset training from cultural musical grammar.
Precisely. Let's look at the tokenization process.
Right. AI doesn't read words. It reads tokens. And the byte pair encoding that these models use for tokenization is heavily optimized for English and Western languages.
Very Western-centric.
Completely. So when the AI encounters Sanskrit, which is a highly phonetic, continuous, and agglutinative language, it fractures those words into unnatural, jagged tokens.
But even if it manages to pronounce those tokens, it hits a second wall.
The rhythm.
The structural rhythm of its training data.
Exactly. The model has learned the phonetic shapes of 50 languages primarily by analyzing pop and rock songs, and those overwhelmingly rely on a standard 4/4 time signature.
So when you force it to sing a Carnatic style, it defaults to its Western-leaning training for the fundamental musical structure.
Right. It takes those fractured Sanskrit tokens and tries to aggressively shoehorn them into a rigid 4/4 pop beat. But an ancient stotra might be written in Anushtubh chandas, a specific meter that just does not map to a 4/4 grid.
So when the ancient meter physically clashes with the AI's internal pop grid, the algorithm encounters an error in alignment.
And it panics.
To resolve the conflict and keep the music flowing, the AI literally drops syllables. It elongates vowels incorrectly, or it hallucinates entirely new phonetic sounds just to make the rhythm mathematically fit the only grid it truly understands.
Knowing the alphabet simply does not equal knowing the grammar of the culture. It is a profound mechanical failure. So where does this leave us? We've systematically proven that no single AI agent today can deliver the holy trinity of digital migration.
That holy trinity being exact, unadulterated lyrics, strict, theoretically perfect raga and tala, and studio quality vocals, all delivered simultaneously in one single workflow.
It just doesn't exist.
That monolithic agent does not exist in the consumer space in 2026.
But we aren't consumers just pressing buttons. We are architects. When a single material fails, you build a composite. Let's construct a practical, immediate hybrid workflow, a pipeline that Murty can use today to migrate this legacy code without losing a shred of its integrity.
Modularity is the key to this architecture. Since we cannot rely on a single system to process both math and language, we isolate the variables.
Okay, lay out the pipeline.
Step one in our hybrid legacy pipeline is creating the instrumental base. For this, we completely strip away the burden of linguistic tokenization from the generative AI.
We take the tools that understand the physics of the sound.
Exactly. We use Sargam AI, or the strict instrumental modes of platforms like Musicful, and we prompt it to build a structurally sound instrumental raga bed.
We specify the exact parameters, say a slow tempo in Raga Kalyani or Bhairavi.
Yes. We let the AI generate the alapana, the melodic bedrock of the sitar, the rhythmic cycles of the mridangam. This ensures that the classical structure remains mathematically and theoretically intact. We build the temple first, entirely without words.
Okay, and once that temple is built, once you have secured that raga true acoustic foundation, We move to step 2, which is the vocal integration. This is where the strict preservation of the legacy code is absolutely paramount.
Because we know generative AI music models will hallucinate the rhythm and phrasing of the stotra, we remove them from the phonetic equation entirely.
We bring specialized intelligence back into the loop. This means layering actual, meticulously recorded human vocals, perhaps, trained vocalists from the Gurukul singing the exact Telugu or Sanskrit Kriti over that AI-generated instrumental bass.
Or, if the project demands an automated scale, you bypass the music generators and use a highly specialized, custom-trained text-to-speech or voice cloning system.
Like an LLM fine-tuned exclusively on Telugu and Sanskrit phonetics.
Yes, and crucially, without any musical timing constraints attached to it. By entirely separating the acoustic musical generation from the linguistic phonetic generation, you elegantly bypass the hallucination cascade.
The math of the raga stays pure in the backing track, and the phonetic transmission of the stotra stays unbroken in the vocal layer.
It is a brilliant, secure methodology for building the core, pristine archive of Project Antaryami.
But, and we do have to acknowledge this, the reality of the digital ecosystem we are migrating into is messy. Content needs to move fast. Algorithms demand engagement.
They do.
What about outreach? What about digital deployment for 60-second shorts, reels, or dynamic intros for media?
That requires a different protocol. That brings us to step 3, content experiments.
Okay, what does that look like?
This is where we deliberately, consciously leverage the creative, improvisational, jazz engine nature of tools like Suno or Udio.
Wait, really? We use them anyway?
Yes. You feed them the traditional lyrics, but you use prompts like AI devotional fusion or modern electronic classical.
Yeah.
You intentionally let the model riff and transform the material. You allow it to create alternative, highly modernized, algorithm-friendly tracks.
But I have to stop and really question this approach. We just spent this entire session designing a meticulous architecture to preserve this ancient text perfectly. If we take this pristine legacy code and willingly let an AI distort it, compress it, and hallucinate over it for a 60-second reel, isn't branding it as fusion just a polite way of compromising the very code we are trying to protect?
Not if you connect it to the broader architectural strategy. It is not a compromise, it is a vital strategic shield.
A shield? How so?
In digital migration, clear labeling is your strongest defense. By explicitly branding these rapid deployment algorithmic tracks as AI devotional fusion, you are actively managing audience expectations. You are instantly disarming the critics.
Okay, I see the architecture here. It's a decoy strategy.
Precisely.
We use the flashy AI-generated fusion tracks to feed the algorithm's insatiable demand for content and draw in a younger demographic. And that public-facing engagement buys us the time, the space, and the cultural bandwidth to meticulously construct the true, unadulterated hybrid archive behind the scenes.
Exactly. You're insulating the core project. You protect Project Antaryami from orthodox, purist criticism because you are never claiming the fusion reel is a strict Carnatic performance.
You're just saying, hey, this is a modern remix.
Right. You are transparently presenting it as a modern digital reflection of the tradition. You expand your digital footprint with the fusion tools, while your core hybrid pipeline and the Sargam AI acoustics, combined with precise phonetic vocal integration, quietly and perfectly preserves the unadulterated legacy code.
You use the jazz engine to paint the billboard, but you use the strict mathematics to build the temple.
That is exactly it.
That is genuinely a masterclass in digital ecosystem management. It elevates this beyond just, playing with AI prompts. You are constructing a resilient pipeline. It's practical. It fiercely protects the integrity of the spiritual work, and it utilizes the AI for what its internal temperature settings are actually good at right now.
It is the demanding reality of our current technological landscape. Extracting this legacy code isn't simply a matter of forcing a language model to sing a song. It is about building a robust, load-bearing architectural bridge between ancient, acoustic, spiritual wisdom, and modern neural pathways.
We have to be the diligent translators.
Between two fundamentally different types of intelligence. One built on divine preservation and the other built on statistical probability.
And that, lead architect Murty BVNS, is exactly the vital, complex work you are doing. You aren't just a passive user of AI tools. You are an architect bridging centuries of human devotion with the absolute frontier of machine learning. It's an incredible mission.
It really is. And as we wrap up today's digital stroll, I want to leave you with one final, lingering thought to mull over as you continue your walk.
A philosophical provocation to test the foundation we've just discussed.
Precisely. We talked earlier about how Research models like RMMM will eventually scale out of the lab.
They will, eventually.
Let's project 5, maybe 10 years into the future.
Yeah.
Let's say the engineers perfect the mathematical rules of the Carnatic Ragas within a consumer neural network.
Okay.
And let's say they perfectly synthesize the Sanskrit and Telugu phonetics, completely eliminating the clash between ancient meter and pop rhythms. The execution becomes theoretically flawlessly one-to-one perfect.
A mathematical certainty.
Right. My question to you is this. Does a machine-generated stotra, no matter how mathematically and phonetically perfect, carry the same spiritual resonance as human bhakti?
Oh. Devotion, by its very definition, requires a conscious soul that has the capacity to surrender. If the math of the raga is flawless and the phonetics are pristine, does the actual soul of the singer still matter to the legacy code?
That is the ultimate profound question at the very heart of Project Antaryami.
It truly is the final frontier of this migration. Thank you for walking with us today. Keep building those bridges. Keep auditing the systems. We are already looking forward to our next Gurukul session with you. Take care.